Hello, everyone. Warm welcome to all of you, and many thanks for joining our session today. I trust to find you doing well and safe, and I hope everybody is enjoying our event this year, again in this virtual conference style. I believe that in the end we are all used to it nowadays, since last year. In this session today, I will cover a very hot topic: how to protect data on-prem or in the cloud with Adabas Encryption for Linux. My name is Luciano Pimenta, and I work at the architecture team in the Adabas Natural business unit. So let's start and build the context around this hot security topic today. And the context is pretty much the same no matter where you run your Adabas databases. So this slide might look familiar to those of you who had the opportunity to watch the Adabas Encryption for ZOS session. The foundation of this topic is really similar, and I start by saying that Adabas is used most of the time in environments of mission-critical applications. By mission-critical applications, I mean Adabas is managing high-value and many times very sensitive data, like, for example, banking transactions, health and citizens' records, corporate financial information, credit card data, passport data, and so on. Actually, we all know how critical our business data is. The databases storing this sensitive information are nowadays highly shared and used by other applications, end users, and API services, even through web applications coming from the mobile phones and eventually external parties and so on. So more and more customers have now a demand for securing their environments in order to protect their infrastructures, communications, applications, and databases as well. For some customers, this is now even mandatory due to compliance regulations from certain industries where they play with. And this means that improving security is sometimes not an optional task anymore. We see that for some customers are even forced to do it nowadays. And to add more to this context on how relevant this is, we see an increase in number of cyber attacks and data leaks, globally speaking. There are organizations experts on this subject. In this case here, ENISA or Verizon that report these figures to the market, and we captured some insights about it to share with you today. And so what is common in these attacks or data leaks? Well, 70% of violations are caused by outsiders, while 86% are financially motivated, and 42% of breaches are coming from web applications, and this number actually more than doubled compared to the previous year, 2019. And who are the victims in general? So we see 72% of it involving larger corporations, while 58% of the victims had compromised personal data, which is usually the preferred target for such crimes. So all of this is pure reality. There's no science fiction here. Of course, another major factor which requires attention is when sensitive Adabas data is stored and processed in public or private cloud infrastructures. This move to the cloud already started, as we see in the field with Adabas natural applications and databases being lifted and shifted to the cloud. In the cloud, the architectures are usually distributed for scalability and high availability, which leads to more communication through the networks connecting those environments. Therefore, data in flight and data at rest use cases need to be secured on this kind of infrastructures. Our software AG response to address all of these challenges coming from the field and customers is a new solution, Adabas Encryption for Linux, where the target is to encrypt sensitive data stored in Adabas, but also allow capability for the encryption of the communications to Adabas. through the network to protect against malicious attacks and data breaches. Now, just a high-level introduction about what is encryption and how it works. So encryption is the process of converting plain data into ciphertext, which cannot be deciphered without access to encryption or decryption key. Decryption is the process of converting encrypted data back to its original form. Decryption of encrypted data requires the decryption key. Without the decryption key, the original information cannot be recovered, of course. Keys are so important, and a key management system is then used to keep track of all keys used to encrypt and decrypt the data. And for us, what was our criteria for database encryption? Let me quickly go through these important aspects. So the solution should cover data at rest and data in flight, while leveraging strong encryption technology available on the platform. It must avoid any negative impact on database performance and operations, and should ensure a non-invasive approach, which means no need to change connected applications. All of the applications must run transparently with encryption. And last but not least, encryption should work on-premise or in the cloud, okay? And how does Adabas Encryption for Linux work? So we secure data in flight, and this is done with TLS, which means Transport Layer Security, formerly known as SSL, or Security Socket Layer as we know it. We are using OpenSSL for this, which means we are using very up-to-date technology in terms of standards. This ensures security for the communications. So we use the new ADA TCP communication interface, which enables pure direct TCP/IP communication to the Adabas nucleus. This is provided or enabled, if you like, by the entire network license key. We also encrypt sensitive Adabas data at rest, as we call it. In this case, we secure the Adabas containers ASO and data. We are using a software-based encryption solution, and we are also very up-to-date in technology by using AES, which is Advanced Encryption Standards with 128-bit or 256-bit encryption key length. The larger the key length is, more secure the encryption is. All of the encryption technology is actually out of the box shipped with Adabas. You just need to unlock it by using the proper license key for it. In regards key stores, by the way, we currently support local file system and from cloud vendors in the future. In case of support for AWS key store, for example, the plan is to have it delivered as a patch for Adabas Encryption for Linux version 7.0. So let me introduce you to one Adabas Encryption for Linux customer case. They are a financial institution in Latin America working with management of cards for banks or retailers and processing of payment methods. They manage sensitive card information stored in Adabas and therefore had requirements for PCI DSS compliance, and annual auditing forced them to protect this sensitive data stored in Adabas. This case also involved a rehosting process from HPUX to Linux x86 in virtualization to consolidate their IT infrastructure. And Adabas Encryption for Linux POV was successfully delivered in 2 weeks' time. The Adabas data was migrated and encrypted, and the natural application was migrated as well, and some critical natural batch processing was tested and proved very successful, same results, and they were all very happy with that. So let me explain the roadmap of Adabas Encryption for Linux. We started the journey in April 2020 in version 6.7.1, where we secured data in flight use case with the encryption of the ADA TCP communication between Adabas clients and the Adabas nucleus, supporting TLS SSL or OpenSSL for that, and this was enabled by a patch 04 for Adabas version 671 in April 2020. Then we just released it in April 2021, the version 7.0, where we can secure data at rest by encrypting the containers ASO and data using advanced encryption standard, or AES if you prefer, with 128-bit or 256-bit encryption. Encryption of database can be done safely in this version by using a format and restoration process. And regarding key management, a file system and AWS key management services will be supported, planned as a patch for Adabas Encryption 7.0, okay? And what are the plans for the future? So for October 2022, we have in the roadmap to launch version 7.10, where we plan to extend the secure data at rest use case by encrypting additional Adabas database assets, like for example, plog, work, sort, and temp, but also encrypt the Adabas backup files. And in terms of key management systems, we plan to support additional key stores. So now let's talk about the prerequisites for Adabas encryption for Linux. We need Adabas on Linux version 7.0 for the data at rest use case. And just to mention, data in flight use case is actually available since patch 04 for Adabas 671 in April 2020, just to recall that. ADA TCP interface is required for the data in flight use case, and for that, a valid entire network server license key is mandatory, the WCP license key. And finally, the Adabas encryption for Linux requires version 7.0.0 and respective AEL license key. LEL is our product code for Adabas encryption for Linux. Some more details about how it works in Adabas encryption for Linux. As mentioned before, we are supporting encryption of data at rest, which applies to ASO and data container files in this current version. So in terms of configuration, it does not require any specific configuration in the NI file, okay? In regards the encryption algorithm, we support the advanced encryption standard, AES, in so-called XTS mode, which is a symmetric key algorithm, where the same key is actually used for encrypting and decrypting the data. XTS AES with a key length of 128 bits and 256 bit are supported, and the default is actually 256 bit. The XTS working mode is actually a typical block cipher mode of operation using block cipher algorithm. So let me explain the process and operations around the encryption of Adabas data at rest. Encryption of ASO and data containers takes place when database is actually formatted. And during runtime, data is encrypted at write I/O and decrypted at read I/O. The encryption settings and the key to encrypt and decrypt data are stored in ASO, in Adabas Associator. That's the encrypted data encryption key, or DEC, as we call it. The key to encrypt and decrypt the data encryption key is stored in an external key management system. That's the key encryption key, or KEK, as we call it. Access to data in database by utilities and client applications is fully transparent, as already mentioned, and important. So for Adabas file-based KMS, that's what we use now, Adabas utilities require access to the KMS file, okay? And this file is located in the /etc folder in the Adabas installation. Without this file, an encrypted database becomes unusable, actually. We are supporting a local file-based key management system and AWS key management service to be delivered as a patch for Adabas encryption for Linux version 7.0. Important note, database encryption cannot be disabled. There are no ADA DBM or ADA OPR utility options that you can just trigger to disable the encryption of a given database. Although this can be operationally achieved, as we will see in the demo part of this session in the end. Okay? So now let me explain to you how to encrypt a non-encrypted database. So actually we can do that in different ways. Let me explain first one, using ADA format, our utility to format a database. So we would start, for example, here with database 12, which is non-encrypted at the moment. And then we would take a backup of this database 12. We'll create BCK001 dataset. After that, we could even clean up or delete the container files of this database to make up some room if you need storage, for example, because we already have the backup. After that, we would run our format utility for database 12, setting the new encryption parameter here, AES256XTS. And then new container files for database 12 would be created, and an entry in the KMS file will be added for this database 12. Okay, so database 12, at this point in time, it will be that the containers are already encrypted and database is ready. After that, we would just then do a normal ADA BCK restore to restore all the data to this new encrypted database 12, okay? So another option is use ADA BCK utility directly. For that, we would take a backup of a non-encrypted database 12. So we start from the backup, BCK001 here, and we would do a ADA BCK restore, setting the encryption parameter to the encryption level that we want, in this case, AES256XTS again. And then the process would detect the database containers does not exist, and would then format the new container files and then do the restoration process, and we will have database 12 created encrypted and the data restored also encrypted, okay? Another alternative would be use ADA BCK restore again, setting another encryption level, for example, in this case here, AES128XTS, but creating a new DBID. In this example here, new DBID equals 17. So I'm trying to create here a test database with a different DBID, in this case, 17. And this can also be achieved through other BCK restore. And then this process would format and restore the database with the new DBID 17, and would add also an entry to the key management system file, okay, and database 17 is also encrypted. Okay, but if by any chance or any means someone needs to unencrypt an encrypted database, so how would it work? So let me explain that. So we would do that using ADA BCK again. So what would be the process? So take as an example database 17, which is encrypted, and we have our KMS file here also. So what would we do? So we would take a backup of this encrypted database. So we take a backup of this. We could then delete the container files at this point because we do have a backup. After that, we would do an ADA BCK restore, set an encryption equals null. And after that, we would have a format and restoration of the database to a non-encrypted database 17 in this case. And after that, of course, the entry for database 17 would be cleaned up from the KMS file, okay? That's how it would work to unencrypt an encrypted database. Okay, so we covered the data at rest use case. Now let's see data in flight use case. In terms of prerequisites, a license for Adabas Encryption for Linux is required for this use case as well, of course. And the ADA TCP or ADA TCPS interface configuration is mandatory in this case. The data in flight use case requires some configuration in our INI configuration file for our database. So for example, we need to set ADA TCP parameter, which by the way, the default is actually no ADA TCP. We have to set TCP attributes like attached buffers for TCP IP communication, TCP connections for a maximum number of TCP connections, TCP receiver for a number of receiver threads, okay? And for the ADA TCP, so we have port number to be set. The default is 49152. Of course, you can set it different if you prefer. And for the ADA TCP-S, which is the secure part of the ADA TCP interface, some other parameters are also required. So for example, SSL port number, which has no default, you need to explicitly set it up. And also additional parameters for the security part, like SSL CA directory, SSL CA file, cert file, key file, password, verify, and so on. So you can refer more to this documentation details in the manual, in the product manual. Okay, now we got to perhaps the most interesting part of the session, the demo. So stay tuned while I switch to my demo environment and we jump into the demo immediately. So let's start our demo. You see here my demo environment. This is a Linux environment where I have my virtual machine running. And we have here some databases. Let me show you quickly. So we will be playing with database 12, okay? And let me quickly do an ADA wrap of this database for you. For example, Zoom. And we see here an ordinary ADA wrap file. The only difference maybe for you is now a new version here, version 7.0, but it's all the things that we show here you knew before. Nothing new for us here. So the goal is to encrypt this database. It shows that it's a standard database now. So what we are going to do, basically, we will first need to stop it, right? So let's stop this database quickly. So first thing now is just take a backup of this database. So let me just run my ADA BCK, the B12, dump echo star. Okay, cool. Let's have a look. Yeah, we have now a BCK 001 data set created. So very cool. So I prepared here a script to format database. So let me just show you here. So my small script is just receiving database ID and encryption mode, as you see here, 2 parameters, and it's basically stopping database, removing the old container files, and then doing the format again with database ID and with the encryption parameter set here with the new encryption setting. Okay, that's basically what it does. No big deal. Let me just run this guy. So we will pass 012 as parameter and AES 256 XTS as our desired encryption parameter. Let's wait for it. And it's there. So it was just created. So after that, what we need to do, let's do a ADA wrap again now. ADA wrap, DB12, zoom again. Now we see something different in the ADA wrap output. You see these 3 lines here. So we see the encryption mode for this database showing that it's encrypted, and the KMS target pointing to the local file, KMS, and the CAC name for this encrypted database is the label, CAC name label, to be able to extract it from the KMS file. So that's cool. So we have it. Now we need to restore the data, right? Because that's actually when the data will be encrypted, when it's restored. Let's do that. ADA-BCK, DB12, restore echo star. Okay, let's see. Okay, now we can see the contents. And we have my demo files again back at this point. So what we need to do now, let's just do something and start it. So let's start database here. Wait a second. Okay, now it started. So let me jump into another session in this same VM, in the same Linux environment, where I want to show you the ADA nuke log of this start. So we see it here, and we have a new message now because database is now encrypted. So you can see database is encrypted message in the adanuc.log. Okay, that's cool. So basically, that's what we need to do to encrypt the database using the format. Okay. But we can also do that using the AdaBCK. Okay, so let's do this now with AdaBCK. So we start with this database, which is up and running already. So we stop it again. So I already have a backup of it. So remember, I would need to take a backup, but I have a backup already. Let's have a look. Yeah, you see BCK001 is there. So I have it. So what I need to do now is just basically remove the containers of this database. So let me do that. I will remove the database containers. Database 12. Okay, I was removed. So now what I need to do is AdaBCK restore everything, encryption equals AES 256 XTS. That's all I need to do basically. Of course, I need to provide the DB parameter as well. Okay, so it verified that the containers were not existing, and therefore the encryption would happen when the container files would be formatted. So, and you see this message here showing that database will be encrypted, and then the container files being created by the format utility, okay? And the restoration processing happening afterwards. So we have it. We could then just do an AdaRep B12 zoom, and we see again the encryption information in the AdaRep output, okay? So moving forward with our demo, so let's assume I want to create a demo database, for example, database 17. And how would I do that? So what I need to do, I would take the backup from the previous database, database 12, and I would just do AdaBCK restore, star, set the encryption mode that I want for this. And in this case, we will use AES 128 XTS just to show you this possibility. And I would set the new DBID parameter to 17, okay? Let's go. Okay, containers for 17 was not existing before. Database will be encrypted as well. Then its database containers were formatted here, and then the restoration was done in the end. Okay, so very good. Let me just clean the screen for you. AdaRep DB17 zoom, and you have the encryption parameters here. And in this case, you see AES 128 XTS. Okay, so very good. That's allowed us to create a test database from the database 12 to database 17. Okay. Now let's assume that I want to unencrypt this database. So that's what I explained it in the slide. So I'll show you now how to do that. So first thing we need to do here is take a backup of this database. So let me just export here and create a BCK001.db17. And after that, let me take the backup, db17 dump star. Okay, cool. So after that, what I need to do, I need to remove the containers of this database 17. So I'll do that by using this rm command. Okay, done. So I don't have the containers anymore. Now what I need to do is do an AdaBCK db17 restore echo star, And setting, important here, encryption equals no. That's exactly what I want to achieve. Restore the database, but removing the encryption. Let's do that. Okay, database was not existing, it was formatted, and the restoration process happened. Let's do a ADA rep now, database 17, zoom. And you see no more encryption information in the ADA rep output, okay? Okay, cool. So let's move then to the last part of the demo, which is the data in-flight use case. So to do that, let me switch here to my other VM. You see database 12 is up and running and it's encrypted as we've seen before, but it's not up at the moment because we had shut it down. So what we are going to do now, we just need to include some parameters in the configuration file of this database. Remember, there are extra parameters for this. So for example, let me just read here some parameters that I have already prepared, okay? So that I don't need to type it, tcp s params.txt. So I'm including here some parameters for TCP IP communication. So you see ADA TCP, so you see port equals 0. So here a hint for you, if you want to disable completely the non-secure port, so just set it to 0 and set the SSL port instead and set it to 62012 in my case and provide the certificate and the keys that I want to use for this database encrypted communication. So I just save it and I start it. Let's wait a bit, just a moment. And right after that, let's have a look at the IADA log again. So what we see here, we see that the containers are encrypted, the message is still there, database is encrypted, but now we see extra information here for the ADA TCP SSL communication. So it says that the SSL is activated, enabled, and listening on port 62012, okay? And all the information about which certificates and keys are being used. Okay, cool. So we have a listening port now for this database. And it's there. So what I'm going to do next? So I'm just jumping into another VM, another Linux environment here that I have. So this is just a natural environment in this case. So what I'm going to do, the plan is to use this natural environment to do a remote access to that database on the other VM. So this VM is on IP 140, as you can see here, while the other is in IP 195. So let me just do something here. First thing I need to do is change my DB mapping file, okay? So this mapping file in the Adabas client allows me to define where to find my database. So I want to access database 12 using ADA TCP S, as you can see here in this line, and I say where this database is located. So I put here the IP address of the VM where database 12 is running and which port it's running, is listening, and I put the extra parameters providing the keys that I want to use to allow me to access that secure database. So I had already prepared this line, just uncommented it and explained to you what needs to be done here. Just save it, and now I just start my natural session, setting UDB, default database, to 12 in this case. So here I just have some high complex program just to show you. I'm just doing a find in employees with city name equals Paris and displaying some information. And I can just run it now, and we see data coming from Adabas. So, and if I come back here to the database machine, and I can just, for example, do an ADA OPR, then DB12, display equals user queue. So I will see my user coming from the remote node, and you see node ID called not ONL1. So that's my remote machine where Natro is running, and it's then connected here. We can also see, for example, through netstat, we'll see an entry here for this part of the database. Okay, and if I just then finish my transaction on the other VM, just switch it back to the other VM, finish my transaction, finalized my Natro session. If I come back here, okay, I don't see that port being used anymore. And if I do an OPR again, database 12, display user queue, and the user had closed its session with Adabas. Okay. Okay, cool. That was the idea of the demo. Okay. Show the data at rest use case with encrypting Adabas container files in the database, and then also encrypting the communications to Adabas coming from a remote Natro application running in another VM. Okay, hope you liked the demo and hope it was helpful to provide a comprehensive understanding of how Adabas encryption for Linux works and operates. Well, as we come to the end, let me summarize here some of the reasons why Adabas encryption for Linux is important for securing Adabas on-premise or in the cloud. So it protects sensitive data stored in Adabas by encrypting data at rest and data in flight. It supports state-of-the-art security standards, so it protects data without any application changes, no changes at all from the application point of view. And last but not least, it's easy to set up and to operate, as you could see in the demo part of our session today. Please feel free to reach out to us if you want to discuss more about Adabas encryption for Linux. Well, I hope you liked the session today, and thank you very much for attending. Enjoy your day, and bye-bye.